Good morning, everyone. Today is the session 3 from the chapter of moving charges and magnetism, and the topic is magnetic force on a current carrying conductor. So, this is a small conductor which I have made on this board. इसका जो क्रॉस सेक्शन एरिया है वो A है एंड इसकी जो लेंथ जो है मैंने ली हुई दैट इज इक्वल टू L. नाउ दिस कंडक्टर इज प्लेस्ड इन एन एक्सटर्नल मैग्नेटिक फील्ड. नाउ ये जो मैंने क्रॉस बनाया हुआ है दिस इज डिपिक्टिंग द डायरेक्शन ऑफ द मैग्नेटिक फील्ड. एज आई हैव टोल्ड यू इन द सेशन नंबर 1 दैट अगर किसी भी दिस क्रॉस का मतलब ये है कि द डायरेक्शन ऑफ द मैग्नेटिक फील्ड इज डायरेक्टेड इनटू द प्लेन ऑफ ए पेपर एंड ये जो अगर डॉट है ऐसे तो ये है दिस इज इंडिकेटिंग द डायरेक्शन ऑफ द मैग्नेटिक फील्ड अवे फ्रॉम द प्लेन ऑफ द पेपर. सो यहाँ इसमें क्या हुआ कि आई हैव टेकन द magnetic field means this conductor is placed in a magnetic field which is directed into the plane of a paper. So now in this session we will be deriving the equation for the total magnetic force which will be exerted on a current carrying conductor when it is placed in an external magnetic field. So let us say that the let us consider that the density of the density of the mobile charge in the conductor is mobile charge in the conductor is equal to n, and this density is basically it is the density per unit volume. ठीक है. सो अगर एरिया ऑफ क्रॉस सेक्शन ए है और एल इसकी लेंथ है सो द टोटल आपका जो इसके अंदर अगर डेंसिटी ऑफ द मोबाइल चार्ज इज इक्वल टू एन एंड इफ एन इज द डेंसिटी पर यूनिट वॉल्यूम देन द टोटल नंबर ऑफ चार्ज कितना हो जाएगा इस कंडक्टर में. The total number of charge is equal to n a into L, where n is the a is the cross section area of this conductor, L is की length हो जाएगी, and since the density of the mobile charge is equal since the density of the mobile charge per unit volume is equal to n, so the total number of charge will be equal to n into a into L. So total value of charge कितना होगा? Total you can say the total magnitude of the charge, or you can say the total value of the charge कितना हो जाएगा. Now ये जो मोबाइल चार्जेस हैं बेसिकली दीज आर द फ्री इलेक्ट्रॉन्स. ठीक है. सो अब इलेक्ट्रॉन्स की वजह से जो है आपका एज वी ऑल नो दैट the movement of the free electrons constitute an electric current. So अब एक इलेक्ट्रॉन के ऊपर जो चार्ज है that is equal to E होता है. ठीक है ना. the magnitude of charge on an electron is given by E. So यहाँ पर लिख देंगे the total magnitude of the charges है ना which is present in this conductor which will be equal to n a L into E. ठीक है. ये हो गया. Now the electrons which are in this conductor, now when they are moving then they collide with the positive ions, or you can say the positive charges. So in that case what happens, the electrons when they collide with the positive charges their velocity becomes zero, and then they again attain the some velocity, and they again collide with some positive charge. So what happens that what happens that these electrons, they keep on colliding with the positive charge. Their velocity becomes zero, then they attain a certain velocity, and then they again collide with the positive charge, and then the velocity again becomes zero. So this phenomena keeps on happening. So in this case, what we take is, we take the drift velocity of electron, or can say that what is the drift velocity. Let first of all, let the drift velocity of electron is equal to Vd. ये हम लोग we have already studied in the chapter of current, जिसका current electricity. So वहाँ पर हमने ये पढ़ा था. So we the symbol of this drift velocity of an electron is equal to Vd. So Vd is what? It is basically the average velocity of an electron between two successive collisions. ठीक है ना. अभी एक पॉजिटिव चार्ज से जब वो कोलाइड करेगा, जैसे ही वो कोलाइड करेगा तो उसकी वेलोसिटी हो जाएगी जीरो, एंड देन अगेन इट विल अटेन some velocity, and then again it will collide. So the drift velocity is what? Basically it is the average velocity between two successive collisions of this electron with a positively charged particle. So ये हमने Vd ले लिया. So the magnetic force क्या है? Magnetic force जो है इस केस में क्या हो जाएगा? Which will be given by, I am just denoting this magnetic force as Fb. So Fb will be equal to, is given by Q Vb sin थीटा. अब साइन थीटा, यहाँ पे थीटा क्या है? यहाँ पे आपका 90 डिग्री हो जाएगा. सो दैट्स वाई यहाँ पर इसकी वैल्यू आपकी 1 हो जाएगी. सो आई एम सिंपली राइटिंग दिस मैग्नेटिक फोर्स एज Q इंटू V इंटू B. नाउ वेयर B क्या है? वेयर B इज द मैग्नीट्यूड ऑफ द एक्सटर्नल मैग्नेटिक फील्ड. ठीक है ना. इट इज द मैग्नीट्यूड ऑफ द एक्सटर्नल मैग्नेटिक फील्ड. एक्सटर्नल मैग्नेटिक फील्ड. ठीक है. एंड जी हो जाएगा Vd इज द drift velocity of this electron, or you can say this is the average velocity of an electron between two successive collisions, and Q is the amount of charge which is it is the total amount of charge which is equal to N into A into L. So Fb की हम वैल्यू यहाँ लिख लेंगे. ये हो जाएगा मेरा N A L, sorry, the total magnitude of the charges will be equal to N A L into E, where E is the magnitude of charge on one electron. तो ये हो गया into Vd into B. ठीक है. Now I will write it here now. तो यहाँ पे Fb कितना हो गया मेरा? Fb हो जाएगा NaLeVd into B. Now we know that the charge density होती है J. We have already studied in the chapter of current electricity. So J is equal to N NeVd. ठीक है. This is the formula of the current density which we have studied in the chapter of current electricity, and J is also equal to I by A होता है. ठीक है. Where I is the current and A is the cross section area. So यहाँ से अगर हम बात करें, so this we can write this equation, this equation as Fb will be equal to NeVd को जो है NeVd की जगह पर मैं करंट डेंसिटी J लिख दूंगा, एंड NeVd एंड AL into B. ठीक है. नाउ वी नो दैट, नाउ यहाँ पे आप देखेंगे, ये हम इसको लिख सकते हैं JALB. ठीक है ना. और जे ए जो है, जे ए आपकी इस इक्वेशन यहाँ से आप देखेंगे जे इज इक्वल टू आई अपॉन ए. सो आई कैन राइट जे ए की जगह पर मैं आई लगा सकता हूँ. आई कैन सब्सटीट्यूट दिस जे ए बाई आई, विच आई, एंड दिस विल बी एल इंटू बी. ठीक है. So ultimately what we are getting is, that is the magnetic force on this current carrying conductor due to this external magnetic field B is equal to, FB is equal to I L B, where I is the current which is flowing in this conductor, L is the length of the conductor, and B जो है क्या है, B is the magnitude of this external magnetic field. तो ये मेरा एक फॉर्मूला आ जाता है, एंड दिस फॉर्मूला इज वैलिड फॉर अ स्ट्रेट वायर और स्ट्रेट दिस करंट कैरिंग कंडक्टर. अभी अगर ये आपका इफ अगर ये आपका जो कंडक्टर है, इफ इट इज नॉट अ स्ट्रेट वायर, मैं कहता हूँ लेट अस से दिस वायर इज थोड़ा सा इस प्रकार से, लेट अस से लाइक दैट. ठीक है ना, इट्स नॉट स्ट्रेट and the current is flowing in this conductor in this direction. ठीक है. So in that case what we will do is we can find the value of this total force, total you can say the total this magnetic force on this current carrying conductor by considering this conductor of वेरी स्मॉल लीनियर लेंथ. ठीक है ना, ये लीनियर लेंथ मान लीजिए छोटा सा एक है, इसको हम ले लेंगे, वी कैन कंसिडर एज डी एल. सो वी कैन कंसिडर दिस करंट कैरिंग कंडक्टर विच इज नॉट which is not straight. So in that case what we will do is we will divide this current carrying conductor into very very small lengths, you can say linear length of having a length equal to dl. ठीक है ना. So इस केस में क्या होगा, and then what we will do is we will sum all this magnetic force and it can be written as that the total force on the this current carrying conductor which is not straight in length, then in that case the total magnetic force will be equal to the sum of this magnetic force due to this individual very very small linear lengths. That is, we can write it down here as sigma I dl into b. ठीक है ना. So this equation, this FB is equal to I into L into B is true for the conductor which is straight in length. That is, it is if the current carrying conductor is straight, then this formula is applicable. However, if this conductor is not straight, then in that case what we do is we consider that conductor to be made up of very small linear length which we consider as dl, and then what we do is we sum up the magnetic force due to these individual, ठीक है ना, linear length to find the total magnetic force due to an external field on that conductor. ठीक है. So this is what I just wanted to discuss in this session 3, and in the session 4 we will be discussing the total force which is exerted on a conductor in the presence of the external magnetic field and the external electric field. So thank you very much for joining, and have a nice day. Bye.